This is section 8.1, problems 9 and 10. Before we look at those problems, let's look at this symbol. This symbol is called sigma notation, and it looks like a big capital E. It's the Greek letter sigma, so that's it right there. Now, in that symbol, you've got the index of summation, which is the k, and from here we can see k equals 1, and then it stops at 3. And then this is read the sum as k goes from 1 to 3 of 1/2 k squared. So let's look at some problems. So it's kind of like the big S that we had in the previous examples, but it's a more simple, like a formula for that. So what we're going to do is everywhere there's a k, we're going to put in a 2. Now, where am I getting a 2? Well, it tells me right here to put in a 2. And then I'm going to put in a 2, and then I'm going to put in a 3, and then I'm going to put in a 4, and then I'm going to stop. Why am I stopping at 4? Because of that 4. And then once I find when k equals 2, and I find k equals 3, and I find that k equals 4, then I have to add those together, because that's what the big E, which is the summation symbol, means, to add them together. So here we go. We're going to put in 2 first. So we get a negative 1 to the 2 power times 3 to the 2 power. So a negative 1 squared is 1, and 3 squared is 9, and 1 times 9 is 9. So k equals 2, the value is 9. All right, now we're going to do k equals 3. So we get a negative 1 to the 3rd power times 3 to the 3rd power. Negative 1 cubed is a negative 1 times 3 cubed, which is 27. And a negative 1 times 27 is a negative 27. And then we're going to put in the 4. So we get negative 1 to the 4th power times 3 to the 4th power. So negative 1 to the 4th power is 1 times 3 to the 4th power is 81. And there's our 3 values. But we're not done, because again, the summation notation, that great big E-looking thing, that tells us that we're supposed to add those together. So we're going to add the 9 and the negative 27 and the 81. So 9 and 81 is 89 minus 27 gives us 62. I'm sorry, 81 and 9 is 90. And 90 minus 27 gives us 63. So the answer to this problem is 63. All right, let's go into C. So for C, we're going to start with k being 1. That'll give us 1 over 1 plus 1, which is 2. And then we're going to add that to k, which is now 2, over 2 plus 1, which is 3. And we're going to add that, and we're going to keep going all the way until 8. So we get 3 over 4, and 4 over 5, and 5 over 6, and 6 over 7, and 7 over 8, and 8 over 9. Now we have to add those all together. There's no way that you could add those together by hand, because you have to get a common denominator. So you put that in your calculator, and you get 15,551 over the common denominator, which is 2,520, and that would be the answer. All right, let's go back to B. For B, we've got negative 1 to the 0 plus 1 power, which is negative 1 to the 1st power, which is negative 1. That's our k equals 0. Then k equals 1, we get a negative 1 to the 1 plus 1 power, which is negative 1 to the 2nd power, which is 1. And then we get, for k equals 3, we get a negative, or k equals 2, we get a negative 1 to the 2 plus 1 power, which is negative 1 to the 3rd power, which is negative 1. And then for k equals 3, we get a negative 1 to the 3 plus 1 power, which is negative 1 to the 4th power, which is positive 1. And for 4, we get a negative 1 to the 4 plus 1 power, which will be a negative 1 to the 5th power, which is negative 1. And for k equals 5, we get negative 1 to the 5 plus 1 power, which is negative 1 to the 6th power, which is positive 1. Now we're adding these together. So when we add these together, we've got a negative 1 plus 1, which is 0, and another negative 1 plus 1, which is 0, and another negative 1 plus 1, which is 0. So the answer to B is 0.